Hello and welcome. I'm Bill Wake. We're working on a parser combinator library. We're trying to replace that using an evolutionary design approach to replace an old recursive descent parser in our basic interpreter. We are working on expressions. I had hoped to get to statements this morning, but we are still back on expressions, getting close. But this session's a little bit of a bonus session. Normally I do this mornings, Monday through Friday. This is my afternoon on Thursday because I'm going to be out tomorrow. So let's see, back Monday. All right. So we left off. Let's see. So the issue we have is basically error handling. It's kind of an interaction between our wrappers and our type checker and the error handling system. What we're getting is we're getting this expected start of expression. What's supposed to happen is the parser attempts each of these alternatives, and usually in most of them it will fail. When it fails, usually it's because the first character is wrong. This one has to start with a paren. This one starts with a number. This one starts with a variable. Well, this one starts with the words fn, okay, for user-defined functions. And then you have fn like a and parentheses and the contents of the call. What happens is we're parsing it, we're matching it, function a of a string, but we get to the type checking and it fails. And the type checking, there's some question about where it says it failed. And if you say that you fail at the very front of it, then this rule kicks in that says, hey, if you didn't make any real progress, let's just say you failed to start an expression. Let's say we had a plus sign as the first thing. It's not an assignment statement. It's not a number or any of these other things. It's just you can't treat plus as an expression. Okay, so it would say I expected the start of an expression. But if you make progress before you fail, we want to take whoever made the most progress, and if it's any at all, we don't want to use this rule. We want to use the one that made the most. I think it does that. I think the issue is our user-defined call, but we fixed the one for user-defined, so now we just have these predefined ones still, and they're having the same issue. They want to say, oh, it's a type mismatch because you can't call square root of a string, but they got expected start of expression because I think the error checking said, well, we failed right here at the front. You can't, this is not a legal expression. Where we really would have liked, I really would have liked to point here and say a string, it's because it's this string here. That's the mismatch type. But well, we'll have to see. I don't know what's going on. What's going wrong? Okay, well, one thing we did, okay, so we modified function parser, user-defined function parser to use expression parser, which is the recursive type, and that fixed this case, but I think the check user-defined is still an issue. Now, maybe we need to take this off too. I don't know. Because I do have my suspicions that there's something about the way we were wrapping. So let's see if this helps. Expression parser. That's the name, right? Yeah. Okay. That slow compiler throws me off sometimes. But I'm also afraid that the checker is just coming back and saying 0. Yeah. Okay, so let's go find check predefined. Okay, so the argument, the token here All right, let's go back again. That's the predefined function right here. It's complaining. Now maybe it should be complaining after the thing it's got. That might be an acceptable thing for this checker. Let's try that. Okay. So I think I'm going to move it forward one. Okay. So, oh, wait a minute. Did I calling the wrong predefined function call. It's really the type check. Oh, okay. Maybe that's okay here. Yeah, I think the fact that it fails the type check is okay, but we shouldn't be reporting the front of the type check, which is the token. We should at least report like to the parens or to the expression itself. So let's do this. We know it parsed, so we know there is an expression, and let's make sure predefined call. Yeah, it always matches expressions. There's at least one there. That's predefined. Yeah, every predefined function has at least one call. Okay, so one argument, and may have more separated by commas. Yeah. Okay, so I think this moves us forward to at least the beyond the initial parameter of that thing. Okay, and so I think I don't know. I don't use very many messages, but error. Is an arguments not predefined. Okay. Some of this, yeah. I mentioned before lunch, part of the issue is tokens know their locations, but expressions don't. And it would actually be preferable to report the location of the expression. And actually, this can even be a 2. We always know there's at least, we know it parsed, and it can't parse unless it gets to the expression, which it's type checking. Okay, so it's not particular about what it's reporting on. We could get by with 1, but I think this puts it actually in the argument, is in the yeah. Okay. Let's commit that. Fix error reporting for predefined function call to make error. How about to fix type checking, report error in the expression, not the function name. Okay. All right. Now let's get back to expression. Ay. Oh, there's expression. Okay. Let's jump there. All right. Now we have expression parser. These wrap olds should not be necessary. Okay, expression parser. There's one. Okay, let me just search. Okay, that's down there. Good. Well, good. Okay, so this should be neutral. Okay. So use bind to make expression parser be recursive. Good. All right. Now, I do want to do this stuff. Let's see. I think all this down to the bottom, down to there, should be that should be able to be a method, and we should return that. So let's see if it'll extract. No, of course not. Okay. Let's get all the pieces. And gonna replace this. That. Okay. Expression parser equal all that stuff. Return expression parser. Okay. And now this is the expression parser method. Okay. So now this is what we want to do. Return wrap self expression parser method. And we'll comment this out for a moment, but hopefully get rid of it. Run tests. Okay, so let's cut that. Okay, expression parser calls that. All right, so this thing. See, I'm trying to get this thing built in advance. No, oh, excuse me. Part of the goal, like I would really like to say early on, expression parser the field equals expression parser. Okay, hang on. Okay, so expression parser field equals expression parser, and then just reference that directly in here. I don't know if I can. See, it reference. Oh no, we don't reference self in this anymore. Maybe we can do it. Okay, we're going to try an init that creates an expression parser. Oh, and this thing only produces a bind, so that's actually not a hard thing to declare. Okay, let's get up to the top. Okay. All right, so I would like to say let expression parser of type this, and then my init, I want to say expression parser equals expression parser. Can I do that? Can not call value of non-function type. Right. Let's call this make expression parser. Parser invalid. Okay. Yeah, I guess at the top level I can't name it the same as the field. Okay, so are you happy? Self is used in method call before all stored properties are initialized. Oh, how do you do this? Defer. Okay. Cannot assign to property. Okay. I guess I can live with that. I'll defer before all stored properties. Can I do that? Okay. So we're coming out with this thing defined. We have to make it a var because of that. But, okay, this should all work. That's the big thing. All right, and then now, make expression. That thing is being called down here, expression, and it should just call expression parser because it's already been made. Okay. And I think I can do that for any of my parsers. Okay. Now, okay, so move expression parser to declarations. And let's see. Okay, so now who calls expression? That's the question. Expression. Right. All these things. We can inline expression because it's not too big at this point. Calling expression is like calling this. Okay. And we know there's a few. Let's see. Well, actually, we're in the statements now. I guess we can look at this picture a little bit. So the the expressions were very vertical, Boolean or calls Boolean and calls Boolean not, calls sub-expression, calls term, calls factor, calls whatever. This one's much more flat. Parse calls single line, calls statements, calls statement. Yeah, that's deep. But then the flat part is statement is either data or def or dim or for, etc. And I've marked the ones with E that call expressions. So we know 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's what we're up against. The last thing I'll point out in this is the if statement has an arrowhead on both ends because if also calls statement. So once again, we have some mutual recursion, but it's a lot less intense or removed than it was in the other. We'll have to do that same sort of thing for a statement parser. It'll have to be a bind at some point, but we'll get there. We're not there yet. However, we can go through and find these calls to expression. Okay, and now they should become this. Eventually, this will have its own new style parser, and it'll just call expression parser directly. All right. And I'm going to I'll check them. Well, that worked. That's good. Maybe I can do them all. Take a little bigger step now that we know it works for at least one. If then uses expression, yep. On. Print, yeah, definitely. Dim one. I think there's a couple others. Expression. Okay, so nobody else is calling this. There may be some tests. Let's see if any tests are doing that. Build failed. Whoops. Wrap old. Okay, let's just call expression parser here. Nope. Built is good. Hello. So what we're doing is we have a basic interpreter, and it was written using recursive descent parsing. And I'm trying to change it to parser combinator approach, which makes something that looks a lot more like a grammar rule. And we're almost done replacing expressions, which is about half the language, give or take. But we've converted expressions successfully to this new style parser. Big step for us. Okay. And let's make sure everything's good still. Yeah. All right. So we replace expression with the new expression parser. All right. That's a big step. Okay, so that I think we're. I think one more thing that's going to happen is there are references to other parsers. Let's find variable. I know I have a method variable name. Here it is. Okay. This one, we defined an identical parser. So I want to say, let's make the variable parser available. Let's see. So no, it's a parser for basic. So this one we match a variable, and so it's a variable followed by optionally left paren expressions separated by commas, right paren. So it could be either a variable or an array reference. Yeah, Lisp would be a lot easier job because Lisp, um, they say the language fits on a page. It probably fits in about 8 lines to define the syntax for it. It's really, well, the original Lisp anyway, very straightforward syntax. Smalltalk too, same thing. They fit that on a page. Basic, unfortunately, does not. It's yeah, it's not a huge language, but it's got a lot of stuff going on for expressions, really. So a lot of, I think, eight or 10 operator precedence levels. Kind of crazy. Let's see. So we have this variable parser. We use that as part of expressions, but there are a few other places in the language where you can put variables, and so we need to do something for that. Well, it lets you create operators, and it doesn't have every character in the list, but it's got a bunch of. You can actually use a bunch of legal Unicode math characters or anything that's already an operator, kind of combined with some others. I don't know if there's a limit on how many symbols you can string together. I think I've done 3 or 4. But yeah, it's letting you do something pretty good. Let's see. I've got the library. It's a separate library we developed, but um, there it uses a lot of I don't even know the word you use for this. These are generic types, but then this type alias stuff, the parser is it can infer all these types, and so they're very complicated. Yeah, it is. It is that sort of thing. Um, let's see, but it will infer a lot of types. I don't know if I can find one that, well, even this one we're looking at. Let's see. Let's look at the type of this thing, bool or parser. It's this crazy, deeply nested thing. So when you're debugging it, it's no fun. But the expressiveness is so high, it's like, ooh, it really is nice. I mean, this this bit replaced 10 lines of code, and that's pretty good. Um, but anyway, let's see. I got to find my variable again. Whoops, just F variable. Okay, once more variable. Okay, yeah. So you say for loop for x equals 1 to 7. You need to be able to reference the variable. So we, I still don't have variable. Did I call it require variable? No. It's variable parser. Okay. That's that one. This one. Variable. Okay. Dot lesson member. I talking about like these on the match here. These are enums for these names. So I have a token type, and it can be a variable, left paren, comma, and so on. So somewhere there's an enum declaration that says case variable, and then you could say token dot, but it'll infer it if it can figure it out. But there is references to dot something. I don't know if I have any around here. Well, you could call function dot something. Yeah, token.string gets the field out, stuff like that. Arguments.append. Okay. All right. So this variable parser, I want this to be a thing as well. So I'm going to say make variable what's the name got to do with it? Wait a minute. I guess the name is an output at this point. Yeah, so this thing is, I'll call that make variable parser. Okay, and it's going to return well, I don't even need to do that, I don't think. I think I could just pull it. Let's just pull it up to the top. Variable parser equals that. Okay. Never used. Yeah, so I want to make one here. Var variable parser. Actually, I want this to come after. And oh my goodness, what's its type? Some mess. Okay. I think I'm going to do this same trick. I'm going to say bind token producing expression. We'll initialize it to nothing. And then I'll make it here. Variable parser equals bind variable parser dot bind is what we want to parser dot parse. Okay, so what we're saying there, and I know this is on the obscure side. We're saying there is a variable parser. It starts out empty. You can reference it, and we're gonna feed it this parser that we just defined, and that makes it available. Okay, and so make expression parser. Well, let's make sure this works. Crazy, I know. It should build, and nothing calls it, so it shouldn't be a problem. Okay. Right. So now we have variable parser that's defined before expression parser. Make expression parser should be able to use the variable parser that we just defined. Okay. Let's see, where's variable parser being referenced? Okay, it's being referenced in the expression function. Okay. Good. Variable parenthesis. Oops, back. Variable subname. Yeah, that's the one we want. Okay, so this now exists, and this we can inline. They call it parser combinators. Yeah, composition is pretty much what you're doing. You're building parsers that build from parsers. So it's kind of recursive construction of parsers. So as long as you have a base level parser like match one thing, you can build up all the rest by saying, oh, I could string them together in sequence, or I could alternate them, or whatever. And so you're building up a in our case, like that expression one, it's a, it's got 15 rules or something. It's a pretty complicated thing. Um, but with this, now I can use this variable parser, and let's find the callers of this. Okay. So they should be able to say that. Let's make sure that works. Oh. Who is calling parse? Bind before parse. Parse. Let's go back. Why is that not bound? I want to see if we can figure out what object we're calling this on. Parser function nil. Well, how's that being called before my initializer? Interpreter.run. Gather data. But this thing program we call parse. We got parser here. A syntax analyzer, which it's a init should set up that. All right, let me undo. This is being called by somebody. Comma list read. It basically says in the constructor, normally, well, it's called the main part, or the first part, everything before the defer. If you have lets, you can define them, but then you have to make sure they're constructed by the end of the initializer. Defer says after you've constructed all the normal constructor stuff, I'm going to let you do some extra definitions. So it's these expressions are allowed to make use of everything that's pre-constructed, called functions and reference fields and so on. What I'm not getting, okay, I got statement on a read. Must call bind before parse. I don't know how this comma list of variables. So you read x, y. Variable token dot string. That can't really be where it is. It's gotta be in here. Name. That's the parse. Wait a minute. Wrap new.parse. Okay, that's the adapter. Yeah, I don't see how bind is not. Okay. Let's see what I've changed. Okay, I made this available. I filled it in. Instead of variable name, I'm calling wrap new variableParser.parse. I'm using the defined one in the expression. And I'm wrapping variable parse here. Okay, let's put this one back. Let's do try variable name again. Same problem. Same test. Oh. I don't know if there's a way to only see my stuff. That's unfortunate. Find parse. Pipe.parse. Variable. Why is that not bound? That's the part that's throwing me off here. Okay. Let's break in here. I gotta figure out which test this is. Oh, data read tests. Okay. Okay, let's see what his setup is. Maybe he's doing something a little goofy. Create an interactor, create an interpreter, run it. So this is kind of a real full test, end-to-end kind of test. Interpreter.run has to gather data. He calls parse here. And then run loop. What's the gather data? Oh, right there. Okay. We gathered. Oh, we gathered. That's the problem. You can't gather data without a parser. Okay. So what parser it got, I don't know. Is there a default one? Yes. Okay, we changed parsers. Okay. All right, I think this should be better now. No, what do I know? Globals. Well, I don't know if this means anything then. Oh, okay. Maybe this is a bit of a red herring. The problem is, okay, I've got a parser. I would have said when this gets created, I mean, this gather data is going to use that implicitly. All right, so let's run that test again. Oh. Okay, if I step over and print the parser, whoops. Line number 0, value statement 0. Okay, and let's see what. Oh, wait. Parse. Who's creating syntax analyzer? Wait a minute. Parser. Okay. Parser is created. Parse is not. Okay, so at this point, let's look at parser. Which has a bunch of stuff. Probably too much. Okay. Parser. Okay. Here's a lexer. Here's a bunch of predefined functions. Let's see. I want to see parser.variableExpression. Parser.variableParser. A re-extraction func helper. Cool. With unmangled suffix 173. I don't know what that means. Okay. It's a bind. Okay. Print variable parser.variableParser dot. I think it's parser function. It's certainly not nil. it's some parser thing, right? It's got a slice and an out. Okay, let's print that equals nil. Should be false. Is nil is false. Okay, good. It says it has a variable parser bound. Okay. And let's step over and in. Okay. And let's look at this again. It is not nil. And let's do the same for expression parser. Okay, not nil. All right, so I'm gonna jump here, break here, continue. Okay, print self, that's too big, print variable parser, it's not nil, print expression parser, not nil. Okay. Single line, statement. And then it was the read case. Continue, step in, common list of variables. Okay. Variable parser is still there. Okay. Over there. Let's go in. Okay. I'm going to go in here. Break here. Continue. Okay. Let's print. That's a lot. I guess it's going to be a read statement. Integer read, variable x, left paren integer 8. Yes, you're allowed to do all that. Okay. Parse. Okay, this let's look at parser. It should be our bind thing. And that's a non-nil function. Okay, I'm going to step in. Now, what the heck? Okay. Well, it sure looks like that thing is bound. Now it's nil. What? Okay, let's run that test again. Where's that test? Interpreter. I'm not remembering which function was failing. Gather data something. Can read into array cell. Okay, I'm going to let this move forward. 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 Read. Read into array cell. And if I go, okay, print parser function. I don't know, is this precondition thing not working like I think it does? Parser function is not nil. Okay, and if I step over, and now I print parser function, it's still not nil. Okay, what if I call parser function sub input? Make sure this precondition thing is doing what I think it is. If it evaluates to false, in other words, if precondition is nil, I don't know. Well, it's some sort of read statement. Data read tests. And that's an interesting read, but okay, let's try this one. Precondition. If I get over here and I print variable parser, sure looks like, I mean, a thunk is a closure, and so I assume it's got the parse function that we defined. Variable parser dot parse of That's not going to work. Missing variable name. Well, that's actually what we would expect. It means it's calling something. So variable parser is not nil at this point. Let's look at it deeper. Variable parser. He's only got one field, which is this parse function. Okay, I'm going to continue. Oh, that one worked. Let's continue. That looks good. Let's go back up here and look at variable parser. Variable parser dot parse empty input. Same thing. Okay, let's continue. 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 Okay, that test is happy. What's going on? Okay. Read numbers worked. How's read multiple? Trickier. Ooh. Okay, what this test can read numbers into array cell. Okay, this is the recursion. Okay, I maybe know what I'm doing. All right, I gotta make sure. Yes, that's an issue. So this thing matches expression parser, which we did a bind here, but we didn't bind. Oh no, is that right? That's right. We've got two different things bound. So I made this initially empty, but we need to do, let's see. Make definition. He created a new one. Expression parser.bind. Yes, that creates a new one. Sorry. I think what happened is we got bound to the initial one that had empty, and that's the one that's complaining all the time. But expression parser, let's see. I think if I take this out, I'm getting side effects, but I'm binding it here. I almost want to return. Now this might be okay. Let's try this, but I think it needs some cleanup. Okay. Right. Let's check it in. So I think just to make sure what we're doing. Okay, we're binding variable parser. Okay, yep, that comes out. That comes out. Yeah, so the variable parser here got bound to two different expression parsers. One, the initial one, and then the one, then there's the real one, and they don't tie to each other, or did not tie to each other. Okay, so make variable parser and expression parser defined in constructor. Now the type of this thing is ugly, right? Because it's just big. Okay, so what I think I can do, bind token expression. That is okay. I think I can use a different bind. Okay, so if I return bind of parser function, which is bool or parser.parse, okay, then that implicitly binds that one. This lets me explain the type. It's just tokens go to expressions rather than that giant expression that is the true definition of this type. Okay, so it's a different variation of bind. This one binds it right at constructor time, and it just lets me kind of simplify the types as I pass them back. This then has to happen up here. Okay, constructor. Right. Bind, make expression parser. Parens. Okay, this should still pass. Cannot convert bind to .parse. Got to pass the parse function. Oh golly. Okay. Let's hand back. Let's make expression hands back a parser that gets assigned to expression parser in the constructor. All right. Well, I'm glad my tasks were catching stuff, but my goodness. Okay. So we're looking for, let's find assign again. Assign name. Yes, variable. Try variable name. We should be able to do this now. Try wrap new variable parser.parse. Okay, so I'm calling the new style parser. That should work. Okay, now if I find more variable, not require, but this one. Okay, I should be able to do the same thing. Let's go in the method. I should be able to return this instead of that. Okay. So we're using new parser in common list of variables. Okay, this is the second place in there, so it should be the same. Okay. And I think both these, they're no longer using name. Name is no longer used. Variable is used, yes. So variable parser. Okay. It's really the same thing. Two in the same method. Top variable name is different. Function variable, let's see who calls it. Hopefully we're running low. Good. All right. This, let's go back to our statements and let's just work them one at a time. Okay, so let's find data. Go in here. Okay, so a data statement is we're going to match the token data. We are going to find a bunch of strings. So we're getting strings separated by values. Okay. All right, so we got the word data. We don't need the left hand of it, so we don't need that part. Well, we'll keep this. It's a sequence of data followed by, and then it should be a string, match string, with the message expected a data value. And then these, they get gathered together into an array of strings. That's fine. Separated by commas. Okay, so ampersands match dot comma. And I think that ends the statement. Yeah. Okay, so that should get us that handles the parsing part. We need when we get these strings, we're going to get an array of tokens. This gets ignored. We get an array of tokens. Okay, so we're going to have to send it to a make data statement. Make data function. Okay, and make data takes an array of tokens. Well, it's really strings. Is an array of token. And well, it just does data of strings. Oh, I think we can just do that directly. Okay. Data of strings. Strings is $0. It's the string contents. Let's make the function. Okay, make data takes array string of tokens. So let's make. We're going to return a dot data with an array of strings. Dot data. Well, let's call this tokens. This strings equals tokens dot map to $0 dot string. Okay, and return data of strings. Okay, and we can call it directly here. Try wrap new self data parser dot parse. Comment out all this. Whoa. Value of type tuple. Value of tuple type. Oh, this thing returns a statement. Oh, okay. Missing return. Two failures. Okay. Expected a data value. Extra characters and a line. Well, I see what's happening. Not sure how to quite fix that. So what happens is we do match X, and then it's looking for comma another variable, and it doesn't see it. So it says, well, you've got one X. That's legal so far. And then, so it says, as far as I can tell, this is the good part of the statement. And it stops here, and then the checker at the end of the line says, hey, did you have any stuff left over after you parse this thing? I think that is legit. Now, can we get that message coming out? Well, I can see a way to do it. I could let this thing match non-existent strings and then complain if any of them were non-existent. Is that a good way? then I would have to check. I'd have to add a checker function for it. So this is kind of a consequence of the recursive descent versus combinator approach. So combinator approach, it's willing to backtrack, and recursive descent, normally you don't structure it so it can. So combinators are top-down backtracking, and recursive descent is top-down no backtracking. And because it backtracks, it says, I got as far as I got, and then it looked bad. And recursive descent just says, look here, this is I'm totally expecting something. So the combinator approach is happy if the prefix of a statement is a statement, and then the rest of the line can be marked as, I didn't know what to do here. I don't know how much I care, but if you had commas, well, I mean, this would be a better message to be, right here. Yeah. Okay, let's do that. That's a good example of kind of an interaction between error handling. We're revising our grammar to allow for things, for likely mistakes. And I say likely because I'm pretty sure CSV format, you can have empty values like this. So I could kind of believe that might happen. Or you might think, oh, it does not going to care about the last comma, but it does. So we're going to change this just to get this message, okay? And so the function for this is check data, and it's given a list of optional tokens, and it produces int string, which is the error message. Okay. Ew. Will it have an error to report? Maybe this isn't necessary. I'm going to have to make it even more ridiculous. I'm just not going to do that. I said at the start I would let you put different error messages, and I'm willing to change the messages if it reports it at the same place. I think that is exactly what's going on here. Okay, sorry. Yeah, so I said I'd take a whoa, wait a minute. It's actually the other way around, isn't it? Oh, okay. Should be getting this. A data value. Is that correct? What? Make data missing return token. All right. Let's run these. Okay. So I'm getting a better message. I like it. All right. Oh, am I getting a... No, I think that's the value I got. Okay, I guess I got myself tangled up and excited. Okay. Um, all right, syntax analyzer. Now, data. We can get rid of all this. I mean, it's an improvement. All right, now this, we can inline data. It's only called once. Okay, and I'm gonna paste the statement up here and the call down here. DataParser.parse, yes. Okay. Let's make sure we have no can't happens. We still have something going on with dims. Okay. We will... a little parser handle it. Okay, fair enough. Let's see. Define. Okay, so this is define parser, and it is match define def match def followed by function match function followed by a variable maybe not quite sure here. I don't want that, but I do want the variable. That's semantics. Then left parenthesis. Left parenthesis and a variable. Require variable. I guess we want this string maybe. variable. Okay. And match variable with the message. Variable is required. And this one was the function. Require function. Variable. This one. I'm not sure we're going to get our variable. Our messages. Name, token, count. That's semantics. Left parent, variable, right parent. Keep that, but we don't care about the parentheses. Match a right parent. I don't know if I can say this. Match dot equals. Equals that to parameter definition. Okay. Then an expression parser. Yikes. Okay, this is expression parser. And that may be it. Okay, and then that's semantics. Wowzers. Okay, I think this... I don't really care about the equals. But I don't think I can get rid of it either. Okay. Def function variable parend variable parend equals expression. Yes, that's actually what it is. Left parend. Missing left parend. Yeah, that's normal. Okay. Now, this, unfortunately, it is going to produce some horrendous type, like really horrendous. Okay. And we have to call a semantic function for it. So we need a check function. We got to check the variable name. And I guess that's okay. Somewhere we'd require a float. Yeah, this has to be a float. Probably this variable. Okay. All right. So it goes to check. Is that the right? Yeah, and then this one is make def statement. Okay, and this is check. Okay, and they take the same arguments. Oh, function check def statement. And it's going to take an argument, and I don't even know. Well, let's see. It's not going to need this, but it is going to need this. But I think I ignore that. I'm hoping I just get a token. Well, it's going to be a pair. A token. We'll match that. We'll match that. I think this is like this. And match variable. We need that variable, so it's a token, and then it's an expression. So I think this is token expression. Well, that's could be worse. Produces int string. Lots of tokens. Expected. Okay, let's just return dot skip. Return nil. And make def statement should be the same. But it should return a statement. Okay. And yeah, we don't want a nil. Let's return skip for now. This is int string optional. Pipe to make def statement. Okay. Cannot convert. Yeah, that's afraid of. Okay. Cannot convert value of token. Token expression to expected argument type, aka expression. So, okay, I guess I'm losing something here. Match this and keep the right-hand side. And ignore the left-hand side that we just kept and keep the variable. Really keep it. Match the variable. Keep it. Match right parent. Match equals. I think I'm going to need some parentheses. Okay, so this keeps the right, so it should keep only the variable. Keep the left. Okay, I think this expression match, but keep the right, and that. Okay, I think that's a variable token. Is the message changed? Expression. Let's do a build again. Expression optional. String. Okay. Let's let the def part equal this. Okay, and I'm going to send that to our check function, our make function. It should complain. Cannot convert to token, goes to statement. So that's what I do want that to be a token. Okay. Now this one should be def part and match variable. Keep that. Well, maybe I don't need it. If I do this right, I should just be able to parenthesize. Match that. Keep the left. Keep the left. Okay. And then keep left. Why not? This should give me a token, the variable name of the function. This should be the parameter. Let's see. Let's pipe this. Make def. Cannot convert token to statement. Well, this looks like a token too then. I think that part's good. Token. This should be array of tokens. Token. Why doesn't that conform? Bind token, token, token. How did I get 3 tokens there? Token, token, token. Bind token expression. Expression is an expression. I don't know. I thought this thing should be... I thought it should be giving me a tuple here. All this was to convince it, like, hey, put a token, token in a tuple with an expression. All right, let me... Okay. Let's see. Are we going to solve this in 10 minutes? I don't know. If I have 2 incompatible types going to an ampersand, my understanding was they would make a tuple. So if they're the same type, they make an array. And then tuple. So SAT1 and SAT2, SAT1 produces a number, an int. SAT2 produces a double. You should get a tuple with the int and the double. Now I thought I had a tuple with tuples at some point. Array yields arrays. But tuple, maybe there's it's the and then tuple array. And then element array. Okay. Where it's an array of the same types. Okay. Okay. So, I mean, this doesn't apply because the elements, the 2 tokens, I thought would make an array. Excuse me. Okay, so this is puzzling me for sure. This type.
Let's go take him to Henry. Thank you. Let's go find Henry.
Well, this one produced a token. Let's make sure this all sounds right. Make def.
Make them play in 5 minutes.
Cannot convert value of token expression to expected argument type. Okay, let me why is this token expression? I mean, that's what I want. To expected argument. Oh, expected argument type. It is token to statement. Make data statement token expression cannot apply to this. It sounds backwards the way they're saying it, but I think they're saying this keep left, satisfy, blah, blah, is not compatible with that because it's just a token, which is what I expect it to be. This one should have the same thing. It should be another token. I want to get the variable out. Token, token expression. To token to statement. So those are two tokens. And I would have thought this type would be array of token. Token expression to, and it's a tuple. But okay. That's cannot be applied to bind. Bind token, token, token. Bind token expression. Let's just make sure this is not a parenthesis thing here. Don't think it is. Well, let's try the same trick here. Bind expression parser dot parse that. Bind token token, bind token expression. That doesn't matter. What puzzles me is this part. To me, this part should create an array of two tokens. And instead it's doing a tuple. This one that I want to do a tuple is not doing a tuple. It's the same operator. Okay. And this stuff is just so... These variations, they're just easy to screw up. But I thought... I don't know if I have the test cases to prove it, but I thought... And then array element, no. And then array. If I have two parsers producing this, taking the same input and producing the same output, then the target of this should be and then array. So I'm just puzzled. So the one that I thought would produce and then array of the two tokens doesn't seem to apply. It seems to have created and then tuple. With token and token. I don't think I can say... Well, I can't say it there. I don't think I can say not. So I'd like to say p1.target not equal p2.target. To really just reinforce that. These two have to be equal because they're the same type. I don't think the order should matter. And then down here is the operators. P1, two parsers of the same type produce an array. Two parsers. Okay, maybe I should be doing binding. We'll give that a quick try here. Bind diff.parse and okay, and pipe that to make def statement and see what complained. These should be an array? No. Oh, that's an array. Okay, okay. Let's try this. Tokens. We apply to type and then array. Well, bind token. This is array of tokens and expression. See, I think this is and then array element. And then array element. Okay. P1 target equals P2 target, array of P2 targets. Okay, that is not the case. P1 target is array of token and P2 target, array of P2 target is array of expression. So this should not apply. And then array element. It should be and then tuple. Okay, let me see if I can just use the operator here. Like that. Cannot convert. Okay, now my types are messed up. Array of tokens with an expression pair. Okay. I don't know how I missed the combination that does that. But this is array of token. This is, I think it's just expression. Same thing here. 2 tokens and an expression. Okay. Okay, so that doesn't apply. This, let's see if we can get this away. I think we show that it didn't detect it properly. Type slice. Yeah, it's parse. Oh, take the parse off. Cannot convert token to expression. Well, I don't know if I can say that. Okay. A long road to get there, unfortunately. But we are there. So what I have is this parser, I believe, is correct for these pieces that it pulls out the variable, and the expression and passes those into check and make def. Now we want to apply these rules, like the name count has to be 1 and whatever else there is. This has to be a float type. So we want to check those two rules. And then we want to do the composition. Okay, so we'll pick up there next time, which will be Monday. And this has been a tougher one than I thought it would. And there's a hole somewhere that I need this. I don't know what it is. And it may be possible I can't quite get the type system to bend that far, but I'll live with this. I'm making a tuple out of these two things. I'll live with it. All right. Thanks for joining. I hope to catch you in the future, and have a good weekend since I won't be back till Monday. Take care. Bye-bye.